Okay, this is lesson 9.4, which is writing equations of quadratics by using their roots. So before we do this, I want to do these three problems, which is just reviewing how to graph. Okay, and I'm going to choose to graph just by using the roots and probably the vertex. If I need to, I'll use the y-intercept. So let's graph this quadratic. I'm going to first solve for the roots. The roots will always be at y equals 0. Okay, so I'll substitute 0 in. 0 equals x squared minus 6x. Now, when I try to do this, I realize that there's no c term. So if you want to, you can add 0 and do everything the same. But this has a GCF. So I'm going to divide both terms by x. And I'm left with 0 equals x times the quantity x minus 6. And I'm going to set each factors equal to 0. So x equals 0 and x minus 6, so I add 6. X equals 6. These are my two roots. So the equations 0, 0, and 6, 0. 0, 0, and 6, 0. These are my roots. 0, 0, 6, 0. These are my roots. Okay, let's go ahead and find the vertex. The vertex will always be at x equals negative b over 2a. So a equals 1, b equals a negative 6, and c equals 0. So x equals a negative b divided by 2a. So x equals 6 over 2, x equals 3. So the x-coordinate's 3. I'm going to substitute the x-coordinate back into the original equation so that I can solve for y. 3 squared is 9. 6 times 3 is 18. 9 minus 18 is a negative 9. So the coordinate of my vertex, 3, negative 9. Okay, quickly let's solve for the y-intercept. It's at x equals 0, so y equals 0 squared minus 6 times 0, which means y equals 0. The y-intercept is 0, 0, which makes sense. So what is special about this problem? What's special is that the y-intercept is also a root. So that 1.00 is both a y-intercept and a root. Okay. Let's go ahead and graph number 2. Graph the quadratic. So I'm going to first solve for the roots. It's at y equals 0. So I'll substitute in 0 for y. Now, when I'm factoring something like this, you have to remember that a has to be a positive 1. So my first step is going to be divide by a negative 1. So then I'm left with negative 1 parentheses x squared minus 9. Now, this is actually the difference of squares, but if you're confused, there's no bx term. So I'm going to add in 0x minus 9. So I need two numbers that multiply together to get negative 9, combined to give me 0. That's 3 and 3, if one's negative and one's positive. Set both factors equal to 0. Add 3 on both sides. X equals 3, subtract 3, x equals negative 3. So the roots are 3, 0, and negative 3, 0. I go ahead and graph that. Let's go ahead and solve for the vertex. The vertex is always going to be at x equals negative b over 2a. It's going to be at the axis of symmetry. A equals a negative 1. B, there is no b term. C is 9. So x equals a negative b over 2a. 0 divided by 2, which is 0. Okay. Substitute 0 back in, and you get y to equal 9. So the coordinate of the vertex, 0, 9. And you know what? This is also the y-intercept because it intercepts the y-axis right there. So what is special about this problem? Well, besides the fact that we had to know that there was a plus 0x here, we also realized that the vertex is the y-intercept. Okay. Last one of these graphing. Graph the quadratic. So we're going to go ahead and start with the roots again. Roots are going to be at, y equals 0. So the roots are going to be 0 equals x squared minus 6x plus 9. In order to solve this equation, solve for x, we need to factor. Two numbers that multiply together get 9. 9 and 1, 3 and 3. Combine to give me a negative 6. That'd be negative 3 minus 3. I need to set both of these equal to 0. Add 3. X equals 3. And our roots are 3, 0, and 3, 0. So really, our root is only 3, 0. This is what we call a double root, meaning that there's actually only one root, and the binomials are just two of the same things, because technically this is a perfect square. So 3, 0 is our only root. Let's solve for our vertex. I think it's going to help us understand what's happening here. So our vertex is at negative b over 2a. So a equals 1, b equals negative 6, and c equals 9. So x equals a negative b over 2a. So the x coordinate is 3. I'm going to substitute it back in. 3 squared is 9 minus 18 plus 9. 9 minus 18 is negative 9. Negative 9 plus 9 is 0. So the coordinate of my vertex is 3, 0. Which means that my root is also the vertex. Okay, so this is my axis of symmetry. Just want to make sure we're clear about that. Kind of confusing, so let's go ahead and solve for the y-intercept. It's at x equals 0. So y equals 0 squared minus 6 times 0 plus 9. 0 minus 0 plus 9, which means y equals 9. So the coordinate of the y-intercept, 0, 9. Go ahead and reflect it. And there's my quadratic. So really, this is the kind of situation where if it's a perfect square, we're going to have what's called a double root, and it's going to be also the vertex. So what's special? The vertex is the root. And this is always going to be true when there is a double root. It's called double root. Okay, go ahead and play the next video for writing the equations of graphs.